Can you see my screen and can you hear me?
Looks good. We see you and your screen. Everything looks awesome.
Perfect. Then I started off. Once more, thanks very much for the invitation. Thanks very much to have the opportunity to present a use case today on NMOS ISO 4 and how to discover inventory and manage inventory in a world where you have ISO 4 compatible and proprietary broadcast infrastructure. First of all, my name is Thomas Gunkel. I'm working for Skyline Communications. It's a company with about 350 people. What we are doing, we do open monitoring and orchestration solutions specifically for the media and broadband industry. Our product, you might have heard about this, it's called Data Miner. It's an off-the-shelf platform, a framework to manage IT, media, broadband infrastructure with a focus on service orchestration, lifecycle orchestration, as we call it, service monitoring, but also, and this is what we look into today, to manage technical, operational business processes. And one of those is inventory management, where NMOS ISO 4 plays in. Before we have a look into the use case, just a few trends on the industry when it comes to inventory management. All of our customers, when we have discussions with them, they are really after a single source of truth. So when you manage your inventory, you want to have one database, one system, a single inventory to document just everything. Your physical inventory, your virtual inventory, your wiring, your IP addresses, all together, a single database. That's the ideal case. It needs to be consistent. Such database, such management platform needs to be in sync all the time with the real situation in the network. And so it doesn't help a lot when you have a database that's getting outdated over time because you're doing changing in the network. Also, when you look into the dynamics compared probably to the good old SDI days, where everything was pretty static, nowadays we have a much more dynamic situation. We have still physical inventory, but changing a lot more, and a lot more virtual network inventory, VNI, that you spin up in the cloud on demand, for example. You also need to manage that kind of inventory as well in one or the other way. Big topic, security. Here it's all about inventory management and onboarding in a controlled way to make sure you only use equipment when you have secured the onboarding, have the right software, have the right configuration, have changed your passwords, etc., to be able to use it to make sure you have good inventory in your network. And how do you do that? At the end, it's all about automation. Whatever you do with inventory management, you need to automate each and every process as far as possible. A few aspects in inventory management. It starts with discovery. How can you discover new inventory? You can scan the network and see if you get a reaction from something in the network that to find new equipment, or you connect to a database. And this is really where NMOS ISO 4 comes into play. To say ISO 4 is there, devices register itself in the registry, and the management system can get notified through the ISO 4 registry when there is something new. But there is more to it than just discovery of new inventory. Every inventory management system needs to somehow provision the inventory, needs to be able to manage the inventory by itself. And then you also need to make sure you need to configure the inventory with the right base configuration, golden configuration before you use your equipment. You need to make sure you have the right firmware running, the right software image, etc., to have something that you can use which is ready for production. Let's have a look into two use cases, NMOS ISO 4 infrastructure and proprietary non-NMOS infrastructure. With the NMOS infrastructure, as you know, the NMOS capable devices, they register themselves in an NMOS registry. And then there is a management platform that talks again to that registry via that NMOS query API to get notified whenever a new device registers itself or disappears again. If you have non-NMOS infrastructure, you need to do it in a bit of a different way. You can scan the network. Scanning the network means you fire certain commands to the network. If you get an answer from a device, you can find out who that device is. If that's a switch, if that's probably a camera, any other infrastructure can be detected in such a way. Or you have another database. Large companies, they're all using CMDB databases when they buy new equipment. they register the new equipment in that database. That could also trigger some processes in a management platform to onboard new devices, new infrastructure. How do we store all that data, no matter if it's an NMOS device or a non-NMOS device? We store those things in a so-called CI type. What is that? It's a configuration item type, CI types. Stands for, when you Google for it, to identify the required attributes and relationships that comprise a configuration record. So everything you need to configure your equipment, and that includes hardware, but also software. That can be any kind of documents and even users, people, that are stored in a, say, CI type. It's administrative data and all the logic you need to configure your devices. Let's have a quick look into the non-NMOS workflow. How do you discover a non-NMOS device or infrastructure? You need to scan the network. Certain IP ranges where you know whenever you add a new switch, new gear, you scan it and you are able to find it. Then you need to provision the equipment in your management platform. And once you have provisioned the equipment, once it's a manageable device, then you can use a proprietary API. We call it a connector to start interfacing with that infrastructure, to read and control the device. And that's today not only SNMP anymore. Many of those connectors we are building, they are based on multiple APIs, a mix of REST, something JSON, SNMP, OpenConfig, etc. So that initial life cycle is really, you need to discover, you need to provision. Then there is this transitioning phase from when an equipment is not ready yet until it's ready for you to be used in production, to control, monitor, manage, and orchestrate the equipment. And how do we do that? We store information in CI types, we said. We need discovery profiles. We need to store somewhere which command do I need to send to the network and what kind of response do I expect. And that can be SNMP commands, that can be HTTP, HTTPS commands, WMI, Telnet. There's many protocols out there, many different types of commands to find and detect your infrastructure. And just a few examples here on the right-hand side. For example, when we fire a sysobject_id SNMP command and we get a value back that starts with this, we know this is unique. This is an Arista 7010 switch. Very similar, bit of a different ending here. We know this is an Arista 7050 switch. Or same for Cisco. If it has that value in an SNMP MIP2, we know this is a Cisco switch, or we can also detect operating systems. Just a few examples here. Once we have discovered a new device type, new infrastructure, we need to provision the equipment. There's many things we need to do at the end. First of all, you need to give it a name in your management system. And some naming conventions. Where do you store it? In our system, we call it a view, like a tree structure. You need to logically arrange your equipment somehow. Then most important, which is the connector, which is the driver you interface with to your equipment. Here is a small example again of an Arista switch. Let me enlarge that a bit. We give it a name, and then you have to specify a protocol version, a connector version, because you might have Arista switches, just an example, running a certain firmware. Then you might have newer ones. They need a different kind of API. You need to enter all the credentials, IP addresses, etc. automatically, different APIs, how to interface with such equipment. Then you also want to maybe specify some alarm and trend templates. What are the parameters I want to monitor against? Which are the parameters I want to store data to see some trend over time? You might have to enter your default password that you can start communicating with those devices. And once it's there, you also need to define, do I want to use it immediately or do I set it to a paused mode? So many things you need to configure to provision your equipment. And maybe even more, for example, to add additional URLs to your existing CMDB database to get information on the rack location, power consumption, to do some calculations with your infrastructure. And only then you have what we call a managed element. And then you can start communicating with the element, communicating with the infrastructure and get all the information from there. Once more, a few examples of a switch like this one here. Each and every interface, real-time information on the bit rate, on, let's make this a bit bigger again, on SFP data. If you have optics, fiber optics in there, or some RTP flow information to track your multicast, it's all the raw data you can read, and you can configure each and every metric that's allowed by the API. Let's have a look into equipment that talks NMOS, ISO 4. New equipment you connect to the network, it registers itself to the NMOS registry. Then your management platform, instead of scanning the network, simply subscribes to the NMOS registry, gets notified. In our case, we do this again via a connector, ISO 4 connector, as we say, that implements that NMOS query API. And then we can do the same thing again. Once we know there is something new, we can start provisioning the NMOS node. It's the same workflow. It's not ready yet, then it's ready, and we can start communicating with that node. That could be via an NMOS ISO 5, ISO 8, ISO 7 protocol, or any other API, or even a mix of multiple APIs to build one of those connectors again. Few more details here. In our lab, we were using an NMOS registry from Mellanox, but could also be any other registry. We have that ISO 4 query API. We interface with the registry. The new node registers with the ISO 4 registry. Then our connector detects the new node, and that's most important, identifies if the element exists already in the management platform, because a camera might have been there before, you disconnect it, you bring it back online. The management system needs to identify that, or maybe it's a new node, then there is a bit of a different workflow required. Those are just screenshots here from that registry connector, where you have to specify the version. That's important. There are different versions out there of ISO 4 registries from different vendors. And once the connection has been established, it runs more or less 24/7, and we start collecting all the real-time data you get from that registry. Those are the nodes, devices, sources, flows, senders, receivers, subscriptions. That's a screenshot from the senders. We have access to the manifest file, to the SDP information, and it's all there, but we still need to provision the equipment in our management platform. And depending on if that's a new node or an existing node, we have to run different, we call it processes, based on a token which is created by that ISO 4 connector. So if there is a new node being detected, something we have never seen before, the management platform tries to communicate directly with that new device through the API, or NMOS ISO 5 or ISO 7 or ISO 8, to discover that data source and then provision it in the management platform. Or if that's a new existing a node that was in there before and existed already, but has now a different IP address, for example, we also have to identify that, because we don't want to lose historical data from that infrastructure. So we need to adapt the CI type, maybe adapt the firmware, the software, because there were things changing, but make sure we re-identify that this node was existing in the system before. So once we have run that process, again, we have a new element, same as before for non-NMOS devices. And here, for the engineers in the call, how do we sync the managed element in our system with the NMOS registry? We do this via the ISO 4 node GUID. So that's unique. That's according to the specification, to say whenever there is a node ID, that GUID, that must be universally unique on hardware. On virtual nodes, that can be slightly different. If a virtual node disappears and comes back, there might be a new node ID. Then we would also create a new element. But that's the way how we make sure that we are always in sync with the ISO 4 registry and don't lose connectivity to it. Once more, a few screenshots how that looks like. Once we have provisioned the node, we can access again each and every metric, function, feature of a device. And that's an example from a Riedel Muon, X-Embryonics. Let's make this a bit bigger once more, where you see the data pages, information on the license, the firmware, here the flows, video flows, audio flows, everything around the network, again, to read and configure your device. Another example, slightly different because it has a different feature set. That's an Imagine SNP IP gateway. Once more, all the details of the device. Here is a screenshot of the IP video, raw data, all your multicast addresses that have been configured that you still want to configure. More information here on the color corrector, for example, that you can also configure here. Those are features, those are settings which are not available through any NMOS specifications, but we get those through their native API. Or some more examples here to monitor PTP and to configure the PTP profiles, etc., because this is acting as a PTP slave device. So altogether, each and every metric, again, we can access through those APIs. So where are we now? We have the management platform. We can discover new equipment either through NMOS or through a network scan. We have provisioned it. Are we done yet? Probably not. There's still a few more things to be done. Very often you also want to learn about how everything is connected to each other. To discover connectivity, you should automate that piece of the puzzle as well. And then, as we initially said, you need to do a little more with your infrastructure. You need to make sure it has the right configuration, the right firmware, the right software image running before you actually use it. So more pieces still missing. Provisioning only is not enough. How do we do that? Once more with CI types. To manage a configuration, to discover connectivity, firmware, there are not many standards out, or maybe there is no standard out, as Wes pointed out before. There are so many standards, but not for everything. We have a standard. For those kind of things we do here, this is pretty often dedicated to each and every vendor device type, that we do some scripts there to specifically configure one or the other device via automation scripts under the hood. Just a few more examples. Connectivity discovery, that works nicely, for example, with LLDP tables. We can get from Cisco, Juniper, Huawei, Arista, etc., to learn about LLDP tables, get that information from the device, and then to automatically build things like this here, dashboards with some network topology views, some real-time KPIs we get from the devices. You see the switches, you see some media edge devices, and once more, you have real-time information of your network status, fully automated. Software firmware management, very briefly here. Such management platform, you typically store the desired firmware you want to have in your facility and compare that against the firmware of your, in this case, Cisco Arista gear here in our screenshot example. And if it's running the wrong firmware, too old or too new, you might upgrade or downgrade the firmware either immediately or at a certain point in time during the week. Configuration management, that's more about the initial configuration, golden configurations. You want to be able to load a golden configuration, store a template, do some mask configuration, compare different configurations to immediately identify if there was a change, etc., to make sure you have everything set up as it should be before you use your equipment. One more feature here, pretty often requested by IT teams to automatically build rec views. That's also something in the past we did pretty much on a manual way to build those drawings, AutoCAD drawings, etc. That can also be automated. As soon as you know, maybe from a CMDB database, where your equipment should be located, and very often you have that information in an Excel sheet or in a large CMDB database, then we can use that context as well and build those rec views automatically. And when to use all those processes? Some of them, like NMOS ISO4, you typically run just 24/7. Whenever there is a change, a new device appears, or some device, a node disappears, you want to get notified, you do or execute a certain process. For others, like Firmware management, you just don't want to do this immediately. You might have some maintenance slots. You want to plan those maintenance slots. Very granular. I guess that's important to say for some network infrastructure. I do my maintenance upgrade slot during the weekend. For some other infrastructure, I want to do it once per day or whenever I have some time to do that, even only once per month. But it needs to be automated and configured in a very granular way to make sure you do the right things at the right time. And only then, so far we discussed only the onboarding process. Only when you have done all those steps from discovery until you have some production ready equipment, then you can really use it. And here is just one simple example. We have onboarded new equipment, sources and destinations, senders, receivers, and you want to add those to your SDN controller. To establish connections between sources, destinations via proprietary interfaces or NMOS, ISO5, ISO8 specs to do some audio control. How do you do that? You could imagine one workflow. Whenever I found something, I have successfully onboarded a source or a destination, I just add it to my SDN controller. But very often, that's not what customers want. You want to have some, or you need some extra approval workflow. Again, something you need to automate. Somebody to say, yeah, this is a source I want to have as part of my SDN controller. This is a destination I want to add now. There could be several steps. That's also something, think about it, to automate that process from once you have things ready to add it to your actual applications or functions you need on a daily basis to your operational environment. There is more to it. Why is that required? Approving it. You might have rate cards attached to your infrastructure. When you want to do dynamic billing, you have to track the costs. You might have to reserve extra capacity in the network. When there is a new camera coming in, sending out a UHD stream, that might have an impact on your network, on your 10 gig or 100 gig link, and you have to reserve extra capacity or set some host and flow policies. So it's still not enough to have the equipment onboarded successfully. You might to approve certain things, and there's still a lot of extra maybe workflows, automation running under the hood that is required before you can really use your equipment. But in summary, what we have seen with that use case, you can use NMOS ISO4, which is a great tool to discover new infrastructure together with ISO5 to manage connectivity. With infrastructure which is not NMOS compatible. And that's maybe the majority of the projects we see today, that people want to use as much NMOS as possible, but still you see a few vendors or some gear which does not talk ISO4, ISO5 yet, but that can be nicely combined all together. Also, another finding, infrastructure discovery only is not enough to use equipment in production. There's many steps in between you need to do. From discovery, configuration management, software management, provisioning, everything you need to do to have a secure onboarding process. So between ISO4 and between the step when you can use equipment, many other steps might be required. And how to do that, if you do it manually, that it's just too time consuming, takes too long, and it's pretty error prone. And you need to automate as much as possible. And why automating takes too long, but also brings a lot of security. And my last slide here, it's really to avoid this. And we have seen that. This is just a few screenshots from the news when customers and broadcasters and media companies get hacked just because they overlooked maybe one little system running with an old software. They have overseen something that's pretty often a gate for some hackers to get in, just because the onboarding process was not fully automated and people have overseen a few things. And with that, I guess we have probably a few minutes left. I want to wrap it up. Thanks very much. Wes, if there are any questions.
Yep. Okay. So
time now.
You can hear me, right?
Yes, I can.
Okay.
Sorry.
So one question from Martin Persaud. He asks, Thomas, any AI used in this automated fashion? AI, I guess, is the key word there.
Yeah, what we do with data miner, there is AI used. We have some machine learning algorithms already in place specifically to the onboarding. There's not so much AI in use yet, I have to say, but what you can think of, for example, during the onboarding process, we have a lot of customers, they are running their equipment for a few days, maybe even a few weeks before they take it in production. And during that period, when you have a testing period, what we are doing, we are tracking behavior of the equipment. And AI algorithms can be used to do some forecasting and to detect anomalies. And that's probably the most appealing use case here, where we say, with data miner, we have those algorithms to detect an anomaly in the behavior, maybe of an SFP. That's a real use case we see with a few customers already, that the SFP is not behaving as it should be. Sometimes the RX, TX power has some hiccups, goes up and down, but it's not that easy anymore to specify thresholds for those dynamic metrics you see in a network, like SFP metrics, the DOM values there. And what we can do there, instead of specifying a min and max threshold, so when is it good, when is it bad, we just analyze the behavior over time during that testing period, and we can identify anomalies in the behavior. And that will also notify operations to say, hey, have a look, something is not necessarily an error, but not as it was in the last couple of hours or in the last couple of days.
By the way, you can minimize you can stop sharing your screen if you'd like.
Yeah, okay.
Okay. No worries. It always makes things go a little bit better. Yeah. There's another comment here that says there is also PTP monitoring and validation, checking that the end nodes are unified on the PTP domain, whether the end node is participating in the PTP. I guess somebody's just, I guess that's Mr. Welch touting the benefits of what you guys are doing. So that's a good thing. Good. Did you plant him in the audience? No.
Yeah, to answer the question here, or to give you some more insights on PTP, it's part of the onboarding process as well, to have the right PTP configuration. So it's not only the grandmaster, that's something you might be able to set up in a more manual way, you only have one or two, but to manage the boundary clocks and the slave devices, you have your engineered PTP environment. And if you think of a single Arista Cisco switch with 48 or 128 interfaces, 1020 PTP metrics per interface you have to set up, those are a few thousand in a very small environment. And that will be part and is part of that configuration management, to say those are the parameters for each and every interface I need to set specifically to PTP. And once we have done it, again, during that maybe testing period, we are checking if the boundary clocks and the slave devices, the IP gateways, listening to the right grandmaster, have the right settings applied, and also track PTP statistics over time again.
Yeah.
Like the number of PTP announcement messages you get on each and every interface, if you have any anomalies in there. It's a bit of a topic on its own, but it's the same like for every other metric we track and monitor.
Yeah, we're doing a lot of work in one of the SMPTE groups about trying to standardize the PTP measurements that are coming in and make sure that the Yang model is updated for media networks. So there's a lot of subtleties that you have to monitor in a PTP. It's amazing. So, all right. So thank you very much for your presentation. Really,
thank you.
Really enjoyed that today. If